documentation. So a little bit of experiment, I guess, with us. What do you guys expect, right? If I were to tell you to make a requirements documentation for a software, right? Just a messaging software that you use. And let's just say that all we wanted to do is to message a friend and get him to meet with you on Friday night for dinner. What do you expect out of this software? Maybe you could unmute or type in chat.
You would probably want to expect that you can send messages reliably and the other person can receive them reliably.
Okay, so reliable delivery. You said quick delivery times.
The only people who could see your messages are you and the person you're messaging and no one else.
Okay, that's pretty important, right? Because you don't want a third party spying on your conversations. So that's one of the key things that we're going to talk about later on. Okay, so that's a pretty good start. I'm just going to give some examples. Right, for example, messages are delivered. So if you send a message, you expect the other recipient to get it. Right, you want it to be delivered within the time threshold. You don't want it to just, take a year and then it delivers. Right, the Friday night dinner thing might not work very well after that. You want no one else to read your messages, right? You don't want your message to be altered. And you maybe expect the application doesn't lag, and so on. So why should we consider security? There's a couple of things that we want to do, right? Like when you build a messaging application and you just want to satisfy some requirements, who do you target it for, right? You build your application, you have a very specific audience that you want to make it for. Right, so are you making it for stakeholders or using it for the particular users in mind? And most of the time, you're going to do it for users. But then that begs the question, right? Does every user use the application the same way that you expect them to? Right? Security, resources, and information, they contain monetary value or maybe other values that you might not have considered, like reputation. Security breaches is often very damaging to reputation. So imagine if you're Chase Bank, right? If you have a cybersecurity attack every day, your customers might not trust your services very much. So does anybody want to take a guess at when do we usually take security into consideration?
When there's usually like confidential information.
Okay, yeah, if you work for the government, right, you might want to take this into consideration. Jack said critical systems, for sure. If you're making safety critical systems where your failure of the system can impact human life, then you definitely want to consider security, right? You don't want hostage situations going on here. But what we found out, especially for things that are not safety critical and not security sensitive, as in not government security sensitive, is you often have an attack on the system first, and then we consider security, right? So it's often an afterthought. You build your system and then you go, oh, well, we should probably add some security to it. And the issue with that is, well, you're bandaging it. You're just kind of using duct tape to patch over some issues that you have, right? And these band-aids will cause inefficiency and they don't really fully address the issue of the system themselves. So what are some potential impacts, right? So I'm sure you've all heard of WannaCry. It's a virus that's been very popular in the last couple of years, mostly. Right, they've attacked some pretty big names such as NHS, which is UK's national hospital system. Right, if they encrypt all your file and ask you to pay a ransom, do you pay it? For a hospital system, right? If it cripples your entire patient database, well, you probably want to pay that as soon as you can to be able to continue treating your patients, right? So here's an example that I give. If I attack you, right, and I encrypt your entire laptop, your final exam or your exam week is next week, and I ask you for a ransom of everything that you have, right? Do you pay it or do you just take it out? How many of you would pay it? Raise your hand if you would pay it. No, Nobody's going to pay it. Yeah, well, if I encrypt your entire computer and you're never going to get anything back, right? Would you pay it? Backups. Okay, yeah. If you have backups, good for you. So you should definitely occasionally make backups. And that way, if you get hit by a ransom attack, you can always just revert when you need to. Right. So most of the time, you probably don't want to get attacked, right? Even if you don't have anything important on there, it's just straight up annoying to deal with. Okay, so safety. What if you have safety critical systems, right? Somebody mentioned earlier, if oh, well, let's take Dr. Chen's example, right? If you're driving an autonomous car, your Tesla, you're completely autonomous, you're driving down the highway, somebody gives you a message, hey, I'm going to crash your car in 10 seconds if you don't click this button and pay me $2,000 or whatever in Bitcoin, right? Well, do you pay it, right? I will probably pay it, put the car, to the side of the road and, I don't know, walk home, call a taxi, right? I wouldn't really trust the system anymore. So I'm going to give a little bit of definition here, and we're going to ease into a bit of an introduction here. So from National Institution of Science and Foundation, we have this computer security is defined as the protection afforded to some system in order to attain these three key properties: integrity, availability, and confidentiality. So the easy way to remember this is CIA, right? You have the government agency, Central Intelligence Agency, somewhat related to security. Yeah, pretty easy to remember. So confidentiality is where information is basically not disclosed to somebody else. And if we use our messaging application, this is essentially where if you send a message to somebody else, right, only the other person can see it. If you send in a group, whoever is included in a group should be able to see it, but nobody else. Okay, integrity just assumes that things are only changed when they're allowed to change. So you just think of it as the integrity of the message, right? If I send the message, it should actually come from me, right? If you get a message that's signed by Kira, it should actually be signed by Kira. Well, how do you do that when it's digital? We'll talk about that later on. So my example here is if you deliver mail to your best friends overseas, right? How do you know that this message has not been modified? In high school, I remember reading this book. Is Rosencrantz and Guildenstern are dead, and it's a kind of spin-off of Hamlet. And if you remember, in Hamlet is where the king sends Hamlet overseas to another country and gives him a mail. In the mail, it tells him to execute Hamlet upon landing. And while on the ship, Hamlet takes a seal, melts it, opens it up, reads the message, changes the message to execute his friends, which is Rosencrantz and Guildenstern, upon landing instead, puts the letter back in, seals it up. Well, how do you know that the message actually came from the king and not from Hamlet? Well, that's one of the issues with integrity of messages. Availability. And this is just basically if I want to access something in a system and I can access it, right, I should be able to access it. So when we talk about security, I often like to think about my system that I'm trying to protect as some kind of a castle, right? If you think about a castle in the medieval time, you want to defend it against nearby nations, attackers, thieves, and so on, right? And the hard part here is you want to protect the castle, right? You need to find every weakness in this castle and you need to secure them. And that's pretty hard because some of them are not very obvious, right? Obviously you need to secure your main gate, right? You might want a very thick door. You might want guards on each of your side of the castle. But for an attacker, all they have to do is just find one little flaw in your system, right? Sewer tunnels, maybe a bribe guard. And as soon as they find that weakness, then they have access to your castle. So analogously for your system, you need to consider every aspect of it and be able to secure your system that way. But for an attacker, all they have to do is just find one little mistake that you made, one little flaw, and they can get into your system. So some of the security challenges we have, right? And we talked about this with the castle, defending is hard, right? You get a lot of weak points you have to secure. They're not very obvious, right? And attacker really only has to find one exploit. Now, if that's the only thing that you have to consider, it's a little easier, right? You just put a lot of defenses, many layers on your system. But you also have to consider users, right? Users don't like complicated systems. If you're using a computer and it has to restart every hour, well, that's probably annoying, right? The benefit of security is not really considered until a breach occurs. We talked about this before. Usually something happens, right? You get attacked and then you go, oh, well, we need to patch it. We need to add some security to it. In industry, you have usually an IT person, right? Most of the time they're sitting in office, they kind of make memes, drink coffee, and you don't really think much of it, right? You often say like, okay, why did we even hire this guy? Well, if you fire the guy and say your system goes down during Black Friday, well, okay, you got a problem. You're losing a lot of money an hour. So whatever money that you're saving by not hiring an IT guy, you're probably losing when your system goes down, right? And most of the time, users kind of think of them as impediments. So why do we even talk about this, right? Time is money. The key thing is when you go to industry, a lot of times your boss wants you to make a product. And if you're not spending time making the product, you're essentially wasting time for them, right? Monetary consequences are usually not considered until a breach. You make your system, okay, it works, right? Sometimes even if you're not using a banking application, you're just making a website that sells, say, clothes or jewelry. You don't really consider it an issue until, well, say you got an attack and you couldn't use your store for a couple of days. Well, you're losing money every time that your site is down. So when you make a CSE 300 something programs, did you consider security when you developed it, right? I know some of Dr. Owen's classes are incorporating a bit more input checks, making sure that you're really putting in things that you're supposed to. But if you were to do it yourself, would you really consider it? We'll start with a little bit more terminology here. So a security policy is a set of rules and practices that we use to specify or regulate how a system will provide security. And that really is just a set of guidelines, policies to describe it, right? Vulnerabilities is a flaw or system or weakness in the system, right? And you exploit it. And this is just a flaw or weakness, right? Nothing has happened so far. Vulnerability is just describing that specific point of entry. A threat is a potential violation of security, right? So it might be a danger that might exploit your vulnerability. So this could be an attacker, some adversary. And then finally, it's attack, which is an actual threat that's carried out on a vulnerability. Okay, so any questions? If you have any questions, feel free to interrupt me. I will be more than happy to answer them in the middle of the lecture. Okay, so we're going to talk a bit about patches, and I'm sure most of you definitely have used the patches, have used patch before. You go to your Google Play Store or Apple Store, right? Most of the time, they'll tell you to update your applications. So why don't we just use patches to patch away all security issues, right? Does anyone have any input?
What was the question again?
Why don't we just use patches to patch away security issues, right? As they come up, I patch it. Say my application is not exactly safety critical, or let's say it's a calculator, right? It's just a calculator application. So I didn't consider security at all. Why can't I just use patches to patch out security
Well, usually, if you're doing a quality update or a security update, they need to be separate in case the quality update would break the code. And then security updates would be more focused on patching the security parts and not changing any functionality, I think.
Okay, I mean, that could be it.
Okay.
Also, like there's no guarantee that every user is gonna download the patch.
Yeah, so that's one of the biggest things, right? How many of you actually updates your app on a regular basis, right? How many of you updates it as soon as it comes out? For me, I actually got a Windows update sitting on my PC right now. It's been there for a week, right? I don't want to update it. I don't want to lose my progress right now, so I'll leave it there. So most of the times, your users might not actually update your applications. And we've talked about this before, right? Like if you don't really want to use Band-Aid patches to cover up some of the issues that you have with your applications, they don't necessarily solve the underlying issue. And if the adversary can get past your patch, right, if they can melt the band-aid somehow, then that underlying vulnerability is still there and they can still exploit it. So the key thing here is you want to build your applications with security in mind, right? In your software requirement specs, you should have thought about security and you should have baked it into the requirements. So patches in general are just changes made to fix, improve, or update your systems, bug fixes, new features, and so on. And why can't you patch it away? We just talked about it, right? Users don't really update and so on. So security should really be in your original design, right? When you make this, you should have thought about all the security issues that can come into it, or as much as you can, and you should have built a system as secure as you can. And you really should only use patches given as emergency solution, right? Users ignore patches, even if you make a really big message telling them to, hey, update this, or you're leaving yourself very vulnerable, they might not even do it. And if you do it too many times, they really would either not use your app or just start ignoring the message, right? And patches doesn't really fix the fundamental issues. So how can we actually provide security to the system? Well, let's just say the easiest way, right? No access, just completely shut off your system. Well, it's very secure, but that's not really our points of computer science, right? You want to build something that other users can use. So a challenge is, how do you prevent unauthorized access, right? Or attacks on your system while causing the least amount of impediment to legitimate users? And this really is the center point of what we're trying to do in computer security is you want to balance this user experience with the security for the system. For most typical users, they might not see security as a positive thing for your system because they just kind of see it as being annoying. If you have to log in, two-factor authorization for a lot of things, a little annoying. Users might not like that. Let me check my chat real quick. Not everyone updates. Yeah. So I've heard before of this talk of a security plugin where you build your system and then you build this plugin, right? Some kind of class or subsystem that is supposed to handle every single security related aspects of your system. Well, security, just like computer science, is not black magic. We gotta actually build it and we have to incorporate it into our system ourselves, right? You can't just build your system, buy some security plugin from some third party and just have it work. So how should you really design your system, right? When we talk about designing specific system, the SRS and so on, you need to put your users, your stakeholders in mind, and then you create your system to fit their requirements, right? When we talk about security, right, they should be as small, as simple as possible, right? Your modules that you're creating shouldn't really be complex, right? Then it's easier to verify how strong it is, right? You have less flaws, you have less areas that you can go wrong. Open design, right? Your security mechanism, right? Encryption algorithm should always be completely open to the public. It shouldn't be a secret. What's that? This one is a little counterintuitive.
Is
Anybody
that
get a clue?
is that where they document the security so that the public knows the mechanisms that keep the data secure?
So this is where when you make a security mechanism, right? It's displayed to the public. The entire mechanism, say like is open source, to basically everyone can look at it, right? Well, you might say, well, Kira, this is where you might have adversaries that can also look at algorithm and find weaknesses in it. So why do we do that, right? Why do we release our code to everyone else to see?
Oh, well, it allows you to make changes on
You're almost there. You're going the right.
yeah, you can make chance.
Okay, increases the
Of
chance of
finding
a
a zero
white hat
day.
finding a zero. So that's exactly what it is, right?
Okay.
I'm gonna simplify that. Increases the chance of a white hat finding on a 0 day. And what that really is, so Mr. Strasser was going in the right direction, right? You want to allow other experts to review your mechanisms for you. Because remember, when we're designing our own software, we're coding our own stuff, you test it gently. So the reason why we want it to be open design is you allow other people to test the security of your system for you, right? They can find flaws for it. So what a white hat is basically an ethical hacker. So somebody who is working for the greater good, I guess, planning on a 0 day. So what the 0 day is before you deploy the system. So we have this open design, so express in review and point to flaws, right? Reverse engineering can help you figure out if there's an issue to begin with, right? And then the other problem is if you keep it a secret, well, if somebody compromises your system, you might not know about it, right? If they don't know about it, then they have this backdoor that they can just use to access your system whenever you want to, and you will never know that your system has been compromised. So this is pretty important to keep an open design on safety mechanisms. Obviously, to a certain degree, right? You don't want to keep it all completely open, right? Because otherwise you would have to open source your applications, and your company is probably not going to like that. So this is really a guideline, and you need to try to follow as much of it as possible. But again, like use your own discretion to it. Right, and then here's a couple more. Psychological acceptability. Your security mechanism shouldn't really interfere with the users, and we keep talking about this. Your user is going to hate most of the security implementation that you put into it. They find it annoying, right? If you use a messaging application, every time you send a message, you need to put a password, right? Every time you send it 30 seconds, you need a password. That's probably pretty annoying, right? No less of an extreme example is if I have to restart my computer every 12 hours, pretty annoying for me. I don't want to lose my work in the middle of that. And if you don't make it so that it doesn't really interfere with the workflow of the users, they will disarm it. So keep that in mind when you're building your systems. Layering, so multiple layers of security. This is pretty intuitive. You don't want one failure of your security mechanism to completely leave your system open. So you have multiple layers of it to protect yourself. Right. Example here is in your messaging application, you store your messages encrypt in your folder, and you want to also ensure that applications on the same device cannot access these files. For Android, they used to do this. I don't know if they do this anymore, but the things that you store in the applications, some of them are just public to other applications, right? So anyone else make an app on your phone can read other applications' data, unless you specify it. Well, it's good for a reason, right? You might have some cross-application functionality that you want to implement, but at the same time, well, there's a vulnerability by itself, right? I can install some calculator app and then read everything else. And if you make an application that's for a bank and you store a password or some other critical information in there in plain text, somebody else can take that information with your calculator app and steal it. Least astonishments. Oh, no surprises, right? Your functions really conform to what users are using. I'm sure most of you will get annoyed if you press a button and it doesn't exactly do what you expect it to. So hamburger menus, right? The three bars that you see in settings, that should bring up a setting menu, right? When you click on that, it should do exactly as you expect it to. So risk assessments. So to secure your system, we ask ourselves these three questions, and we use this to kind of generate the things that we should do to secure a system, right? So the first thing is, what are you trying to protect against? Is it other government agencies, right? Is it black box hackers? Is it I don't know, is it some amateur, right? Or somebody trying to steal information for if you're making a banking application, right? If you're making a message, is that really annoying third friend trying to join you for dinner when you don't want them to? All right, what do you need to protect? Or sorry, what do you need to protect against is what that is. Okay, what are you trying to protect is what is the system itself containing, right? So messaging applications, you want to protect the messages. You don't want other people to be able to read them, right? Who do you protect against is maybe the annoying third friend. And then how much time, effort, and money you're willing to spend, right? Again, we talked about this. When you develop security related aspects of the system, you need to devote your time on it, which is not time is money. So how much are you willing to spend to secure them? So then this leads to our three key steps, which is you identify your assets, your threats, and then you calculate the risk. And your risk is defined as the expected loss from the probability that a threat will exploit your vulnerability. So let's say I have a system, right? If I exploit, and you can only attack it once. If your exploit will lose you millions of dollars, you might want to spend more money on securing it, right? And if the exploit really only costs $1, right? They attack you, they steal $1, and that's it. Well, you might not really care too much about it. So you need to identify what you're trying to protect, right? you identify who's going to try to attack you, and then you identify, is it worth it, and how much are you willing to put in to protect that specific assets. Okay, so that kind of wraps up the introduction of what I have on security. For the rest of these 2 lectures, I'm going to focus on things that you can do as a developers to help you secure your system, right? And maybe other things that you might see in when you go out and be a developers, what kind of common attacks you might see and what you need to commonly defend against. So before I go on, does anyone have any questions so far? Comments? Okay, so different kinds of attacks that you can consider as a developer, right? First and foremost is I want to talk about denial of service attacks. So does anybody know what a denial of service attack is? Right? Most of the time, you probably ran into this before, even if it's not directly at you.
I think I know. I think that's where they like bombard the system with information until the system can't handle it. I guess is a general way to.
Yeah, so denial of service is basically where you flood a particular system with messages or some sort of services, and you deny legitimate users the ability to use the system. So pretty good example here is a website, right? You use a website, you go into it, it's just a blank white page and it's not loading. Well, there's a pretty good chance that it's actually being DDoS attacked. So what it is we want to make sure that, well, we don't want to make sure. So the attacker wants to make sure that the legitimate users can't use the system or some particular resource on it. And what DDoSing is probably what you will hear more, is a distributed denial of service attack. So you take a bunch of different machines, usually some compromised botnet, and you use them to attack the same system. So it's a distributed attack and it denies services, so DDoS. And this is probably the most common attack that you'll run into in the wild because it requires very little domain knowledge, right? As an attacker, I don't actually need to know anything about networking. I don't need to know anything about your system. I don't need to know anything about how you built it, what the security is on it. All I need to do is I need to spam it with packets, and I don't need to know anything else other than that, right? I might need to know your IP address, but if you're running a website, your IP is public. So I'm going to give you a very, very brief overview of, and I use brief very liberally here, how the web works and just in general how networking works. And if you build an applications, your client will connect to what they call a socket of a server, and that socket is reserved for you. And here I use the analogy of a parking lot. So here's a parking lot, right? It's very scuffed. I have cars coming in from the in direction. I can't draw on this. Yes, I can. Okay, so I got cars coming in from the in direction, and I need to serve each of them. Say there's a mall here, right? So if there's a mall here, I need to serve every one of these cars that come in, and you can only enter the mall after you've parked the car. You don't want to leave your car in the middle of nowhere, right? So every time a car comes in, I'm going to put them in a port. I'm going to put them in a port. I'm going to draw it like this. So all the way until it fills up, right? All the way until it fills up my entire parking lot. So what an attack really is if I put in enough of these bogus cars, right? If I just put in cars that doesn't do anything, and I fill up all of these slots, then new legitimate users that come in and want to use the system, well, they can't because each of these ports are filled. If you imagine if you're running Amazon, right? On Black Friday, say, if your website doesn't work because of this, you're losing a lot of money every second. So here's a classic ping of death attack. And what it is you spam a target with a bunch of packets. And the packets don't really contain anything important in it. You just send them a packet and they just receive it. They take the packet, they read it, and well, it's junk, so they don't do anything with it. And on the right here is an image of my task manager. I ran the attack on myself on my PC with my laptop. So the regular traffic here is down here where you see there's practically no traffic. There's a little bit of traffic because I'm visiting the web here. I'm playing a video in the background to show how much the regular bandwidth is, right? So regularly I have very little, 10 kilobytes per second, very, very little traffic. But as soon as you run a DDoS attack on it, or just a DOS attack, not even a DDoS, right? It spikes up to 32 million bits per second. So actually at this period of time where you have all these packets coming through, I can't even use my computer because it's too busy processing all these packets coming in, right? My mouse wouldn't even move. It's jittery. But it's not very effective coming from one computer because I'm sending a bunch of packets from my computer to another computer. So I'm crippling myself to cripple you. Now, what they usually do is use a botnet, just a bunch of compromised computer, right? A virus to take control of your computer. You might not even know it's doing something in the back that you don't want it to do. And you use these botnets to ping the same victim, right? So if you imagine if I use one computer to ping myself, I can't really use my computer. If I use 10 computers to ping one computer, well, you really can't do anything at that point. And this is basically what the classic ping of a death attack is. Again, requires very little domain knowledge, right? All I need to know is your IP address, and then I just send you random packets. So here's a protocol that we use to kind of mitigate some of these effects of the distributed denial of service attack. So what we use is called a three-way handshake, right? The client wants to connect to a server, so your server is on the side, server, and this is your client. So your client is maybe like your browser, right? Your typical user, and your server is the web page. So your client will send a hello to the server, right? The server acknowledges back with an acknowledgement packet, and then your client responds to that acknowledgement with another acknowledgement. And once you've done that, then your connection is opened here. So pass here is where you basically assign the parking slot to the client in our parking lot example. So with the parking lot example, what if we have the driver request your ticket online, right? Before you come to my parking lot, you have to request a parking ticket online, right? You save some details, right? Car, make, model, year, name, maybe. And once you have that, we'll reserve the space for you, and we put the tag onto the space, right? We tell you like the space is reserved for, I don't know, John Doe with a car with specific make, year, and so on. The driver shows up, right? They put in the ticket, and then they enter the parking lot. They do their thing in the mall, then they leave, which is disconnecting. They leave the mall, and then somebody else can take their spot. So seems like a pretty good protocol, right? You can't just put bogus car in there. You need to reserve a ticket. So put yourself in the space of the attacker, right? What would you do to break the system? Anyone want to take a shot at it?
Maybe just like request every parking space that's open and fill them up.
Yeah, that's one way you can do it, right? You just take a bunch of tickets until you're done. So that's basically what a website attack is, right? You use a bunch of these clients, you take up every single server's capacity, then new legit users are coming in that wants a new connection won't be able to do it. And this is, again, very common. You'll probably run into one, and you will probably run into one in the future. If you're hosting your own website, right, for a small company, you're probably going to run into this. And a lot of times what they do is they would use a DDoS attack on you, and then they send you a ransom note, hey, pay us X amount of money, and then we'll stop your attack. Then you can resume your services. So one of the things that you can do with the example that Jared gave, where you just take a bunch of tickets, is you can check what kind of things that they put into the ticket, right? If they use the same IP address, if they come all from the same address, if they come all from the same area, then you might be a little fishy that you're under attack, right? If all the cars are the same make, all the cars are the same model, they have the same license plate, well, you might go, okay, this isn't very legit. So an example of this is called a TCP SYN attack, right? There's some pretty recent big names. GitHub 2018 was attacked for a bit. Wikipedia, September 2019. I remember I was using the site and suddenly it went down. I couldn't figure what was going on. I thought my internet went out, and a couple days later, I found out that they were actually under a DDoS attack for a while. Consequences, well, again, damage to reputation. If your site is constantly under DDoS attack, your users might not use your service, right? If you're Amazon during Black Friday, this is going to cost you a lot of money. So, like you said, TCP SYN attack is where you just take the ticket online, right? It reserves that spot for you, and then you never show up to claim the spot. So, how do you defend against that? Well, you can't really defend against it entirely. You might just have high volume of traffic just randomly, right? It might be completely legit. If you think of Amazon.com, right? Sometimes you might just have some very random things that happens, holiday shopping. I don't know. So your typical normal distribution, right? Your Gaussian curve looks like this. Oh, the tail's a little scuffed here. Let's do this, right? Most of users are going to peak around like some certain mark, right? So if this is the number of users, 0 users, maybe 100 users, 100,000 users, and so on. There's going to be legit times where you just actually have that many users. So you can't really tell if they're actually legit or not. So you can't really defend against it completely. But what you can do is you can minimize the effects of the DDoS attack. Let me see if I can, oh, that works. Okay, so I can get rid of this. So we do, again, defenses at multiple layer. You can modify your TCP connection node, right? You use what is called a SYN cookie, which you basically drop an incomplete connection when you run out of table. So if you reserve a bunch of tickets, right, you run out of space, you just drop the oldest one that hasn't been used. You kick them out basically, right? Use of CAPTCHA. When you log in, you might sometimes see what they call CAPTCHAs, or you have to click images, right? You human verify that you are actually there and that you want a connection and you're a human. Mirrors and replicated servers. So this is where you basically have identical servers that increases the sizes of your ports. So you can serve more clients with the mirror and replicated servers. What are some of the downsides with using mirror and replicated servers? Right, couldn't I theoretically just spawn, like use 50 million of them?
Don't you have to worry about consistency from server to server?
Sure, but okay, consider I just want to make a website that shows a picture of a cat, right? Who's going to pay for it, right? Servers cost money, right? You have to run it, you set it up physically, it costs money. If you don't have a physical server, you're probably renting it off of Amazon or Google and so on, and they charge you per customer or per server that you're hosting. So it costs money to mirror and replicate servers. And here's our TCP SYN cookie. What it does is you take that information, you store the user's data into this cookie, and this cookie is stored in your browser, right? You add additional information that you want about it, maybe site-specific informations, and you don't really reserve the spot until the car arrives and puts in the ticket at the gate. So when the client actually connects, then you use this cookie with the pre-stored information to create a space for them, right? And then if it's been idle too long, then you kick it out. Again, this is a very, very dumbed down version of how TCP SYN cookie works and networking in general. If you're interested, I have each of these, the blue text are actually embedded links, and you can actually go into quite a bit of detail in it. So that seems pretty good. Not exactly perfect, because we have attacks called, for example, this is called the slow Lars attack. And this is probably one of my favorite attacks because look at how cute that thing is, right? And all it really does is, it's DDoS attack, right? I connect legitimate users to your client, and what I do is I send very little bits of data at a time, like very, very little bits of data at a time. Right? You can't really tell if I'm legit or not because I might just be a legit client with very, very slow connection. Right? You can't just kick somebody out because they have slow connection. That's just not fair. Right? It uses very little bandwidth and processing power of attacker. So as an attacker, I just spawn maybe 5,000 instances of Firefox, right? And I connect to your particular website, and with each of them, every 5 seconds, I send a very, very small packet of data. So I'm basically telling the server, hey, I'm alive, I need more data, I'm just slow, don't kick me out. So when you do this enough, the server basically loses your ability to serve new clients, right? No, anybody has any idea how to defend against this? Don't worry, it's not a trick question. We don't really have a way to defend against Solaris right now. If you do have an interesting idea, come talk to me. We can be very famous, probably. So one of the issues that we're facing with TCP right now is Solaris attack. Last I checked, at least, it was just last year. Okay, so here's a little bit more interesting idea that comes up. If you're working for a big company, you can probably afford to do this. It's called dynamic servers, and this idea comes from some of the online multiplayer games that have stemmed up recently. So what they do is they have this hardware server on their remote, on their actual like location, right? And this it's just made to account for normal amounts of traffic. So your regular, how many players you play with, you just have enough server bandwidth to handle that. And then when you have peak time, so for example, I don't know, at night when people get off work, holidays when they have more time to play, you then just dynamically spin up more servers on clouds. So with this, you rent services with Microsoft, Google, and so on. And when you need more space, you basically create these servers virtually. I have a question for from Tyler. Would it be a lot slower as well? Are you talking about the Solaris attack? Tyler, okay. Oh, more servers? It wouldn't necessarily be slower, right? Because these are still legitimate servers. But the idea is you just don't buy as much hardware servers because they cost a lot more to maintain than necessary. So you accounted for your mean number of clients that you need to handle, and then you just create more when you need to. Does that answer your question? Okay, good. So here's some other websites, resources that I can point you to if you're hosting your own websites. Cloudflare is, I don't know if you've seen this before, if you've visited some websites that are a little bit more popular. They do some DDoS protections, right? Other similar services can also provide your website with some other protections, right? If you host a small business, then DDoS can be very detrimental because if somebody is holding your website hostage, right, you're trying to sell stuff, then you can't really, you're losing money, and they basically want you to pay them before you can resume your access of your website. I'm by no means here promoting for Cloudflare. This is not a paid advertisement, right? It's just some resources that you can look at if you want to. Yeah, I had a student come up to me a couple of years ago when I gave this talk, and they were basically telling me that they host a website for their sisters selling clothes, I think. And occasionally every month they would get an attack from some IP address in Russia, just denying complete access to their website. And then they demand some $2,000 to release the lock. And well, your small business is kind of hard to afford that $2,000 every time somebody comes up to you. So you need to find some way that you can protect yourself from DDoS attacks. So more common attacks that you might see in the wild, phishing. Does anybody know what phishing is? And this is not like going out to the backyard pond, taking a fishing stick and throwing it in the pond to get fishes, right? Go for it. Angela.
Oh,
Yeah, phishing is just when someone pretends to be someone else so they can get you to like log in on something that looks like Facebook, then they get your username and password, or they can do more like social engineering
Very
and
good.
like actually get you in an email chain and get you to reveal like the time and date of some event no one's going to be at work so they can sneak in and steal all your hard drives or something.
Very good. Very good. That is exactly what phishing is, right? It's a social engineering attack where you try to get the users to essentially expose themselves to be attacked, right? Social engineering attack aims to get users to compromise their own system. It's very dangerous because we can't patch this away. There's no amount of good software, right? No matter how you engineer your software, no matter how well you do it, you just cannot patch it away. And again, similar to DDoS, it requires very, very little domain knowledge, right? All you need to do is just you send an email and you pretend to be somebody else. You don't have to know anything about the system. You don't have to actually understand how it works. And you can just social engineering fish your way to compromising a system. So most of the time you masquerade as a very trusted source. For example, you say you're higher up, right? Some manager at company X. It looks very legit. And you use a lot of psychological tricks. For example, time is running out, you need to reset your password soon, right? Netflix, sometimes you might receive some emails from Netflix. If you get one that says, hey, time is running out, you need to renew your bank account information. Should be a little wary of that, you know. Links are scary, links are really scary, so don't just click on any links. Spear phishing is defined as if you craft a specific phishing attack for some individual that you target, right? So Hillary Clinton's campaign staff was attacked by a spear phishing attack in 2016. Here's an example from, this is from Cameron Camp. And what it is PayPal email telling you that, hey, we have some payment issues and we need you to resolve this for us, right? And what you need to do is you need to log in, resolve this at this location link, and they give you this link here, and it looks exactly like PayPal's color, right? If at the first glance you might think that this is actually from PayPal, they got their legit logo and stuff. So this is scary because if you've received emails like this, you might click on it, right? How do you defend against it? Well, you need to know about it. That's the key thing, is you need to know that phishing attacks exist and you need to be vigilant to look out for it. The most important thing that I can tell you is you want to check the domain name of the email, right? Website, email, chasebank.com. This one actually is pretty scary because it's actually, it was, I don't want to click on it because I don't know what it is right now. I think 3 years ago, it was actually a phishing attack site where the site itself looks exactly like Chase Bank, except the hyperlinks that it points to will basically take your login and store it in some attacker's database, right? And the way that they can do this pretty easily. Your websites, you can basically go on any website that you want, inspect the page, and then copy the contents of it, and you can make your site look exactly the same. So as a user, you need to be very careful of these links that look somewhat identical, but missing some characters, or maybe the I's is spelled with L's. You need to be careful of that. .xyz.com domains also pretty sketchy. So be careful when you see those. If you need to reset a password, I cannot stress how important this is, right? If you need to reset a password, don't click on email links. Okay, email links can point you anywhere. They can make it an image, and in that link, they can point you to some website that the attacker wants you to put in their email. Right. So if you need to reset a password, then the best way you can do this is really directly go to their website, right? Google chasebank.com, go to Chase, make sure that it's Chase, and then reset it through their portal that way, right? I got 3 questions in chat. Can't sender email be spoofed? Yeah, sender emails can actually be spoofed. I think some of them are actually harder now, but fake website to get our logins, yes. Clicking links in email to try to get a click. So one of the ones that I ran into before, and this one is probably scarier, is Google's login, right? So you have third-party authentication where you can go on a website like GitHub and you can do login with Google, login with Facebook, right? And if I'm an adversary, I can replace that button to bring up a new tab that looks exactly identical to Google, except maybe the domain doesn't have an E in it, right? googl.com. Now, if I make the login portal exactly identical, right, and I can make you log in with that information, and then use your email and password, redirect you to the legit page of GitHub. Now, you don't even know you've been attacked because to you, you've just logged in with Facebook or Gmail to GitHub. But in reality, that link that you've just clicked on has just took your username and password. So always make sure you check the domain name before you enter your passwords. Right. And then another thing is you can look for sensitive emergencies, right? Hey, do this soon or your service will be terminated. Well, you know, if it's terminated, you need to just think like, is it likely that my account is actually, say, like have payment information issues, right? And then another thing that you can ask yourself is like, does it matter if it's terminated? Can I just resume it once I've updated it, right? So sense of urgency, other psychological tricks, look out for them. Another thing is bad grammar. So a lot of these phishing attacks often have really bad grammars in it. So if you see that, that's probably a good hint that this is not a legit email. Okay, so I have about 20 minutes. I'm going to talk a bit about passwords, and this is probably the most important part of this lecture that I want you to take away from. Okay. Does anybody have the stored password yet in your internships?
Had a stolen password?
No, store. Like, have you had to store passwords? Like, right, build some login functions for the users?
Yes.
Anyone?
I have.
I store all my passwords in a password manager.
Okay, password manager is a good start, but if you have to develop a system, right, for a personal project, okay. So Dr. Owen has actually been starting to teach us with passwords, and it's probably one of the most important things that you can learn from college, in my personal experience, if you're going to industry like this, right? Joseph, when you did it for your personal projects, right, do you care to share? How did you store it?
Sure. Yeah, I mean, like I used Firebase, so like they kind of their auth service just kind of does it all for you. But like, yeah, they do. Yeah, they do use like they hash the passwords basically, so they're not actually storing the strings. They're storing like the hash version of the strings, and they just compare the user input and like see what the hash function generates and see if that matches with what's stored.
All right.
Yeah.
Okay, that sounds good. So you kind of spilled away a bit of my beans here, but that's okay. So passwords are very commonly used, right? You definitely use this in your life, some kind of login, right? MSU has its own password system that you have to use, right? And user accounts basically have a password associated with it. So how do we store these in a database, right? Plain text. Oh, I hope you're not storing it in plain text, right? That would be a very big problem. Encrypted, right? Joseph just kind of gave away my punchline here is, well, you don't actually need to know your user's password, right? As a developer, you don't actually care what their password is. You just need to make sure that it's the right thing. So what we use here is something called a hash. And this concept here like doesn't actually deter a complete attack, right? Like what our goal here is to make it as much of a pain as possible for the attacker to try to steal passwords on the system, right? But you can't really defend against all types of attacks. For entities with really large resources and time, they can crack any password they don't want. Like if it's the US government and they really want a password, I'm sure they have a way that they can crack it. All right, you can try all combinations using a bunch of computers. You're probably gonna get one right. Okay, so again, we don't need to know actually the user's password at all, right? At no point do we need to go back and recover the password. So what we do is we want to take this hash function, right? We take a hash function and we hash the password through it. And a hash function basically takes any input length of characters and it converts it always to a fixed number of characters that is different for every input. And the most standard approaches that we use is called SHA-256 and SHA-512. I got a question. So I've heard about hashing and salting. Okay, so I'm gonna talk about salting in a second here. I'm glad that you have at least heard of that. So what this does is you take any string, right? You always convert it into some gibberish. But the problem, the key point here is every string that is identical always converts to the same message. Okay, and when you change even like a tiny bit of it, right? If you change a 1 to a 2, or if you change lowercase a to a capital A, your output is completely different, right? You cannot trace it. There's no way you can go back from a random string of hash, and you can't go backwards to your original input. Now, one of the issues, if I just take every password, right, and when the user logs in, I hash it, I send it, and then I compare the two, right? I compare what's stored in the database, and I compare the user's input, right? What's the problem with that? Anybody got a guess?
It's not 1-to-1, so they could guess not the right password and still get in, or they could still get your password and get in?
Well, that's not true, right? Because every string always maps to one other string with the hash function, right? And you don't, there's no conflict. So not two strings might not, two strings will never have the same hash value. So when it comes to password, what is the most common thing that people tell you to not do? Just from a user perspective, don't even think about computer science. Don't think about anything about coding. Just as a user, right? What's the first thing that you're told not to do with passwords?
Don't make a simple password like the word password or like
Okay, don't make the pass. Yeah, okay. Don't use the same password multiple times, right? So why? Right? Can you take the two and then guess why?
If they gain access to one site, they have access to pretty much every other site.
Yeah,
Or
yeah, that's one of the key things, right? The key point here I'm trying to reach is when you use common passwords, right? The same common passwords that you use, your hash is always identical. So if I use the password, right, or something very simple, let me in, your result is always going to be the same hash. So what an attacker can do when they compromise the database with user logins is they can pre-compute the hash of very common passwords, right? And then they compare this hash with your database. And if they find a match, then they have compromised your accounts. Right. So our issue here is, right, if you use very weak or common passwords, then we can pre-compute this hash table, the table of hash values, and we compare it with the compromised data. Right. So rocky.txt is a very famous just text document. It just contains very common passwords. You can literally just download it off Google. Actually, as an exercise, you should probably do that. Download it off Google and see if your password is in there, right? If it's in there, you probably want to change it. So you don't want to use just the hash itself, because users with weak passwords will have their information compromised if attacker uses this method. And this table of hashes is called a rainbow hash. But yeah, that's just a little side note. So to answer your questions, what is a salt, Tayo, is basically where we append a very random string, like a complete random string, to the user's password, and then hash it to create a new string. And in the database, what we do is we store this hash right next to the user password. And each time the user wants to log in, right, to enter the password, you append the salt before you hash it, and then you compare. Now, you might ask, well, Kira, you're storing it right next to the password in the database. What is the point, right? So what is the point? You store it right next to the database. Couldn't the attacker still just, take your input, test every single string with it?
do you keep the salt like string encrypted or like obscured
Nope, you just keep
from?
it in plain text right next to the hash of the password. Right, think about what we're trying to do here, right? We're trying to deter the attacker from getting a lot of passwords. So the reason why we have this hash is, if we have a hash, right, every time your hacker wants to compare this value of their quote unquote guess of your password, they have to also append the salt into it. And when you do this for a lot of operations, you're increasing the time that it takes for each guess that they have to make before they can check if it's correct. So what we're doing with the salt is we're basically adding an extra layer of complexity or computational time into the process of brute forcing passwords. Now we can take this concept and expand it one step further and use what is called a pepper. It's kind of a little lazy of a naming when you say salt and pepper password, maybe creative. And what it is it's actually very similar to salt, right? You use another random string, but this is the same string for the entire site. And this is not stored in your database, right? And again, your goal here is to aim to slow down the attackers. And the way that you do this is you store that into just your application itself. So now the user, if an adversary have compromised your database, they also have to compromise your website. So this is your multi-layer defense to secure your passwords, right? And here's an example of what it looks like, right? If I just store the word password, right? Like this is probably the most common password, or maybe QWERTY. And if you do 512 on it, it always comes out to the same string. Always comes out to the same string, right? And if I add a salt to it, this just random string, right? I just generate a random string. I take it and I salt it with the password. Then I hash it. I get this completely new random string. So if I have an attacker and I'm trying to guess passwords, if I do rainbow hash table, I would not ever be able to come up with this hash. Now, the extra layer of defense is when you add pepper to it, right? You take the hash of the old one, you add your pepper string to it, and then you hash your entire thing again. Now, if an attacker is trying to brute force it, right, you have to hash twice, and you have to append a bunch of strings before you compare. And this drastically slows down the attempts of the attacker. So any questions on this so far? This is a key concept that I really want you to come away with this lecture and be able to know how to do, because you will later on in life probably have to implement some kind of password feature. And I do want you to know, like, first of all, I really don't want you to start in plain text, right? And second of all, I want you to have as much information as you can regarding how to store passwords. Okay, so maybe I can go through a little bit more. So when you send this hash, right, you don't want to send the raw password just over the internet for the users, right? So usually what you do is when they log in, you send over the salt from the database to the user's client side. And with the client application, you take their password login, you hash it, and then you send the hash over the internet. Okay, once you have the hash on your client side, you add the pepper, and then you hash the pepper. Then that's your final answer. So here's an example of what it looks like as a table in your database, right? You have a bunch of user informations, right? User login, password, and then you store the salt literally just right next to it. And then your site pepper, which is not stored in the database. Again, this is something that's just built into your application. It's a static string, doesn't change. If you change it, you have to update all the password for the users. But generally, this does not change. This is kept secret for the most part. And you want to just, this is your multi-layer defense, right? Using input password, you take the salt and you compare. Okay, so let's consider from an attacker's perspective, right? If you were trying to steal a password, then how would you do it? Easier to phish than brute. That is very true. I mean, this is, again, like why I said that phishing is probably one of the most dangerous social engineering attack you can do, is because it requires very little domain knowledge, right? If you're trying to brute force a password, you need to, first of all, at least understand how password works, right? You need to understand how salt and pepper works, and then you can try to brute force it, which might take a while, right? Easier to phish, right? Phish, you can just ask the user, hey, I need you to give me your user password so I can help you do X. If 1 in a million user falls out of it, well, you have one account, right? You just send an email to 10 million users, you have 10. So yeah, phishing, right? Try out common passwords. This is probably the most common thing that they will do, is just try a bunch of common passwords, right? Eavesdropping, just try to listen in on conversations, but people don't usually just discuss their password. And then you can try out possible combinations, right? And again, with the try out possible combinations, the idea why we add salt and pepper to the password is to make it as long as possible to guess one password, right? So if it takes, right, if you just store the password in plain text, right, or just a hash, and if each comparison only takes 1 second, right, then I can compare 1,000 of my possible combinations in 1,000 seconds. But if I increase the operation time from each entry, right? So each guess, if it takes 10 seconds to guess it, then 1,000 seconds now becomes 10,000 seconds, and so on. Now, obviously, 1 second to 10 seconds is a pretty drastic amount as an example, but you can imagine if you're brute forcing a bunch of combinations, even a very bit small increases in time will drastically get multiplied. So here's a little bit of a tip from me, I guess, how to secure your own password, right? Very obviously, don't use the same password for multiple sites for the reasons that we talked about before. if two sites are compromised, then your site is, if one site is compromised, then your password is also basically compromised for the other one, right? Some sites will actually store your password in plain text, right? There's actually no federal regulation that says, hey, if you use your application, you have user logins, you need to store it in plain text, right? Particularly for for sites that you don't use a lot, you might not want to, you definitely do not want to use the same password for those sites as your banking account, right? Don't use very simple common password. Again, download that Rocky file and see if you can find your common input to it, right? You'll be surprised. That file is pretty big, and I've definitely found some of my really old password from middle school in it, and yeah, I'm just glad I haven't been attacked since then. So uses, right? Like, so password phrases is something that they introduce, which is a phrase that you like. Here's an example. My favorite book is Great Gatsby with an exclamation mark, right? Very easy to remember. I made up the phrase, but it's pretty hard to guess. So password inputs, I have 5 minutes. Maybe I'll just stop it here. Does anyone have any questions so far for the presentation? Anything about the passwords, anything about attackers in general? If there were some exploit related to database, couldn't both the salt and pepper be exposed? Yes, actually, yes. This is so the idea of the pepper is to be stored separately from the database, right? So the database doesn't actually have the pepper. So that's your multi-layer defense. So if somebody compromises the database, all they have is a salt. Most large-scale password leaks, that kind of depends, because when you think about the concept of like how password are implemented when you do this, you can't really leak a password easily without first finding it, right? If you don't store your password in plain text, it's really hard for an attacker to go through the database and find the exact match and guess your password. So what usually happens is they have this database, right? They steal a database, some entries, and they basically just use this rainbow table that I was talking about, where it's a value of pre-computed hash that are very common passwords. And then they compare it with your database. And if they find a match, then they can convert that to plain text, right? Now there's a leaked password. So if in a database of 50 million users, right? If 1 million of them uses very common passwords, like 1 in 50, which is reasonable, right? Then that's 1 million leaked password that I can provide as an attacker. Does that make sense? Ben, eavesdropping is basically where you're listening in on other people's conversations.
I had a question
Yes.
about Pepper. You said it's stored separately than the database. Where exactly would it be
So
stored?
this is stored
at?
in your application, right? In your application class where you develop the login function, you would literally just store this as a plain text in that class.
Oh, okay, okay.
Right. So again, when somebody wants to attack your site, right, they need to both compromise your database and your application to have both the salt and the password, or the salt and the pepper, to be able to test the password.
Okay.
Okay, any other questions? If you have questions regarding like SRSs too, feel free to ask. We're more than happy to help you. All right, if not, I think that'll be it for today's lecture. We'll be back on Wednesday. Again, your SRS V1 is due then, so make sure that you ensure your consistency checks, and each of your teammates should have proofread the document once. Okay, I don't want to see any spelling errors. If I see like misspelled words, probably will take off points for it. So. All right, well, let us know if you have any more questions.
Thank you for the presentation today.
Yep.
Thank you.
Thank you.
Did you mention whether or not these slides would be posted?
Yes, I'll post them after class.
Okay, wonderful. Thank you so much. I appreciate it. Interesting lecture.
Have a good day.